The modern workplace runs on instant information. Employees expect immediate answers to their questions, and increasingly, they turn to AI chatbots to find them. Imagine an employee needs to check the company's maternity leave policy. They type their question into a standard AI assistant, expecting a quick, reliable number. But standard large language models suffer from a closed-book problem. They can only answer based on the public data they were trained on up to a specific cutoff date. Since the AI has no access to this specific company's private HR documents, it attempts to fill the gap. It provides a confident but generic industry average, telling the employee they have 90 days of leave. In a professional setting, a well-phrased answer is a liability if the facts behind it are wrong. In medical, legal, or strict corporate environments, these hallucinations can lead to severe compliance violations or compromised safety. Fixing this isn't as simple as teaching the AI the new rules. Retraining a massive language model from scratch every time a single HR document or internal wiki gets updated is computationally impossible and financially ruinous. To bridge the gap between fluent language and accurate information, engineers developed an architecture that provides the model with trusted data before it ever begins to write. This is Retrieval-Augmented Generation, or RAG. To understand how RAG works, we have to look at the back-end architecture where a company's private data lives. This is the knowledge source, a massive repository of raw, unstructured materials like PDF policies, internal wikis, spreadsheets, and databases. Raw text files are not built for high-speed AI processing. For a machine to sort through gigabytes of text in milliseconds, that information must be converted into a mathematical format. This conversion is handled by a translation layer called the embedding model. This model translates every sentence and paragraph into sequences of numbers, known as vectors. By converting words into geometry, the system maps the underlying meaning rather than scanning exact keywords. These organized numerical clusters are then permanently housed in a vector database. The company's private knowledge is now a searchable mathematical map that sits separate from the AI's foundational training. Now, let's look at what happens when the employee asks how many maternity leave days are allowed. Before the AI can attempt to answer, an intermediary tool called the retriever intercepts the user's prompt. The retriever instantly converts the user's question into the same numerical format used by the database. The retriever scans the entire vector database at lightning speed. By matching the geometry, it identifies the specific clusters that represent the policy for maternity leave, ignoring everything else. The retriever then translates those specific numbers back into the exact original text from the HR PDF. Next comes the handoff. The retriever passes both the user's original question and that newly extracted HR text directly to the large language model. The language model no longer has to rely on its training memory. It acts as a synthesizer, reading the provided document to formulate its output. The AI delivers an accurate response of 180 days, citing the specific policy it just read. By anchoring the AI in a verified private document, the RAG framework provides the model with the specific context it needs, dramatically reducing the likelihood of a hallucination. This setup allows for seamless updates. If the company's HR policy changes tomorrow, engineers don't have to touch the AI model's code. The organization simply uploads a new PDF to the knowledge source, and the RAG system updates its answers automatically. This pipeline is used across high-stakes industries. Hospitals use RAG to cross-reference patient records with doctor guidelines, ensuring medicine queries are answered based on the latest records. E-commerce platforms use it to check specific product warranty documents, and software developers rely on it to pull precise deployment steps directly from internal wikis. Retrieval-Augmented Generation allows an AI to act less like a student relying on a flawed memory, and more like an expert taking an open-book exam. It proves that the value of enterprise AI is found in its ability to find and apply the exact right documents at the exact right time.